Oh, I got to sit here. Hi, everybody. Well, thanks for coming to our meetup today. So before I kind of dive in and kind of get into some demos and kind of walk through the topic, right, which is around budget and pipelines, I thought it would be useful to sort of go through a little bit of background as to how we came about, how this topic came about, give you a little context around it, and really in context around the DevOps world and what this in particular topic means in a broader context. In order to do that, I think it's kind of important to understand that we all live in a world now where we're going and utilizing the public cloud, and that's pretty easy to use, right? Log in, get a couple of machines running, use a bunch of services, get our app up and running, connect to them, and we're up and running. But from a DevOps perspective, it can be fairly complex, potentially frustrating, mostly because of the fact that the capabilities and services in the hyperscalers are changing on a regular basis. There are cadences on that, right? And as a DevOps person, you always have to balance that change that's coming in, and how do I actually balance that change with trying to ensure that I have a high quality, repeatable, process to deploy something, application, environments, etc. And so you're constantly in sort of a feedback loop and a continually improving process for your deployments and your pipelines. In order to do this, you may do a lot of scripting, duct taping, use a bunch of tools off the shelf. So effectively, what we'll do today is a few things. One, I'm going to kind of cover what some of those baseline practices are to kind of get to what I would like to call going to be a continuously improving pipeline. What are some of the tools around it, off the shelf, open source and commercial. And then we'll get into the specific example that we will cover that will help with regards to your pipelines and deployments, which is surrounding how do I manage budget as I'm effectively going and deploying those applications and environments. So before I go through that, I thought I'd take a minute and really talk about our team, or my team. I'm part of a team of developer advocates here at VMware, and our primary goal and focus is to help you as a either developer or a DevOps person understand how to operate and make utilization of the public cloud more efficient. Our entire life is effectively in Amazon, Azure, or Google, or using Kubernetes. And we do it with the context of an application. So everything you hear today, right, and the demos are actually on our website, cloudjourney.io. And you'll see that entire demo that we'll do with GitLab on there, and a whole bunch of different blog articles and access to our Git pages, right, where we have some of the code that you can utilize and play with. And all of our contact information is there, so we'd love to hear from you and feedback from this and other components. So that's a little bit about us and the team. So let's talk a little bit about that first topic or first component, which is how do I get to this continuously improving pipeline, and how do I manage that and maintain that on a regular basis, right? And it really boils down to really understanding, I guess, some of the best practices and utilizing the right components and tools. There's no one answer here necessarily, right? But and what I want to talk about is sort of the baseline thought process around how you can potentially get there, right? Everybody's process and everybody's deployment pipelines are actually different and are customized to what you need. But there's a way to make this more repeatable and higher quality. And the best way to do this is to talk about the automotive industry, right? And if you think about purchasing cars and buying a car as an example, you kind of have two different options that you can go down, right? We all as mere mortals go to a dealership and buy a car that's off an assembly line. However, if we do have the luxury of potentially going off of that beaten track, we can go and get a custom-built car, right? Now, if you think about a custom-built car, right, that is a very specific product that has been built for your needs based on a set of requirements that you give a custom car shop. Now it's great. It'll meet all the needs that I want, right? Yes, I want a Chevy with flames coming out of it and probably has a nice engine in it. But there's an issue now, right? I paid a lot of money. It's expensive. It's definitely not repeatable because if anything breaks on that, whether it's a fender, something falls apart, it's going to take a while to rebuild that part because it's completely custom. Oh, and by the way, we all kind of watch, TV and, we've got those shows about building custom cars. And if you ever watch how they do it, you might cringe a little while because the quality of that can be questionable. Car is safe. I can drive it down the road and it'll definitely get me from point A to B and meet the needs that I need, and it'll probably meet DMV standards and get my plates. But the quality is fairly questionable, right? So those are some of the drawbacks, right, in a custom car. However, we're all mere mortals. We go down to a dealer and we can't necessarily always afford a custom-built car. And we generally go to a dealer and we'll buy a car that is built off an assembly line. And if you think of a car assembly line, we purchased this car. It's fairly inexpensive, relatively, definitely less than a custom-built car. The components on it are completely, we can find them anywhere. My car breaks down or if the car gets totaled, I can buy an exact replica and a copy elsewhere. And the important thing here is that that car has been built with a specific quality in mind. And it's built in a manufacturing pipeline. And there are multiple pipelines that are going on. If you really think about it, we could take Toyota or GM or BMW, and every single car that they're manufacturing is going through that pipeline. One of the things they do in this is that they have quality control before that pipeline starts. They have quality control during the actual pipeline, multiple stages. And on every single other stage, whether it's a 3 Series, let's say, or a 5 Series, they're also reusing components, right? And they're allowing themselves to effectively get scalable, right? So they can do a significant amount of builds and deliveries of these cars. And that quality is high. Now, okay, I'm not going to get kind of precisely what I need, but it's kind of 90% there. Now, if we take that concept of a automotive assembly line and think about the quality that it goes through to get there, and it's a fairly complex product. One of the things that I think we all sort of want to strive for here is that when you think about a software deployment pipeline, you want to get to that level of quality inside of your CI/CD pipelines, right? You want to be able to ensure that you're not only deploying and delivering that, but it's fairly repeatable, and you're using some common components that allow you to keep that cost down effectively, right? So that's sort of nirvana, right? However, a lot of us actually, and this is true, I would say a large portion or a percentage of the deployments are not done like this, right? They're done like the custom shop, right? They're just put together, slapped in, put out there as fast as possible, and there's a lot of issues potentially afterwards, and you're constantly coming back and looping through that. Just to draw that back, I mean, if we really think about if we follow that same process again for any of the cars, we'd be like welding things on, doing other kind of hacks at the end of the day, and it would not be a perfect car, right? So if we take a look at this from, I guess, a pipeline perspective, and what I was referring to now, bringing it back to the software pipeline, as a developer goes and puts in that the code, we build an artifact, and we start the actual deployment pipeline. We generally have, and we'll call this a traditional pipeline where we may have one or multiple pipelines in multiple stages just to get that component out, whether it's an application, a service, or an environment. And it depends on how your processes are built. Most likely, they're going to be custom. How do you get this to a much larger and broader stage, right? And the way to do that is really to enhance your pipelines by ensuring you have quality checks that are occurring on a single pipeline or multiple stages within the pipeline. And that can be using hand-built tools or off-the-shelf components as needed, right? And particularly, that's what we'll go through today, is how does one of those sort of compliance checks, or in this case, a budget check, work with an external component. And this sort of thought process is important because as you start building out your processes around deployments, you are going to want to be able to repeat those. And if you have some of these pieces built in, you can add them to newer pipelines, you can add them to existing ones and or between stages, and scale very effectively. So what are some of the tools that I can use to effectively get down that path, right? So some of those calls that are made from, as we showed in the previous chart, could be custom built, or you can get them off the shelf. Now, there's different sorts of checks that you can make in your pipeline depending on what your processes need or require, right? And this is not an exhaustive list. But during the pipeline, you may want to check and make sure that your cost is met in your SLA on Amazon, that you're not exceeding it, or on your Kubernetes cluster. You can use CloudHealth by VMware, which is what we're going to show today. You can use CloudIn as another example that's out there. You may want to check if the deployment that's going out there is going into an environment where you have, let's say, a VPC and a set of servers that are out there that it's compliant and the security groups are within a certain, meet a certain sort of rules. So you want to check compliance before you do that application deployment. So you can use Secure State by VMware, Redlock, or something open source like Cloud Custodian as an example. You may want to check image security. There's different variants of this, and I'll show a little bit of this today with GitLab. But you can use Aqua or open source Claire for container scanning effectively, or even like Amazon Inspector for some of the images that are out there. And then obviously some authorization. You can do Turbot and performance detection with things like Wavefront or Datadog. So it really depends on how you are actually building that pipeline and what your effective set of requirements are to make sure that you are comfortable with an endpoint that is higher quality and can effectively be managed, and then the output of that constantly repeated and brought back in so you can constantly refine and keep moving down a better deployment pipeline, right, on a regular basis. So you're continuously improving it. So let's sort of get into the topic area, right? And how do I actually manage that one portion today, right? Which is the budget in a continuously, in my CD pipeline. So what we will do today is to utilize an environment where we're using GitLab for our CI/CD tool set. And we'll show how you can use GitLab in particular at the end of a CI or a build of an image, or a container image, to utilize one of its capabilities, which is container scanning, and it actually goes and uses Claire scanning, and we'll show how that works, and find CVEs. So you can definitely just check at the end of the CI component, hey, is this viable? Do I want to go deploy this or not before it goes into the CD portion? And then as we get through the CD portion, which we'll go through, what we'll do is we'll actually go through a check to see if there is an actual budget violation, or if we're going to be able to overrun the utilization that we have on Amazon, or actually in this case, we're going to use Microsoft Azure, and we're going to use AKS, right? And you can do other checks, and we're not going to go through that today, but there's definitely, we've kind of built some of these out, and you can find some of those examples on our website, cloudjourney.io. So I'm going to hand off now to Ty, who's going to come up and talk a little bit about GitLab, and then we'll come back and do the CI and the CD portions here.
I just gotta press harder. There we go. It was user error. All right. How you guys doing? My name is Ty Davis. I'm from GitLab. I am not going to take up too much of your time because we want to get to the really good stuff, which is how they are using GitLab. I am just going to... Oh, there it is. Let me pull this up here. I'm just going to talk a little bit about GitLab and who we are. Just out of curiosity, raise of hands besides VMware. Who knows what GitLab is or has heard of GitLab? Only a few? No one? All right. So GitLab, we are one of the largest, originally one of the largest source code tools. That's where we started with, and then we brought in the CI/CD piece early on. We came about in 2012. The CEO originally did not want to combine the SCM and CI/CD piece, and he was forcibly by one of the first employees told to do so, and it's worked out very beneficially, or to our benefit, to your benefit. And from there, we have expanded as a tool that is covering, let's see if I can zoom out here, covering a lot of different stages of the DevOps lifecycle. We've defined, in our own way, 10 stages that we believe make up the end-to-end DevOps lifecycle. It started with a few, now it's increased to 10. From manage, plan, create, I'll let you read the rest from, but going from project management to source code, repos, going to CI/CD, incorporating security into it, incorporating monitoring and performance metrics, container packaging, all that inside the GitLab tool itself. With GitLab, we are incorporated in 2000, off the top of my 12, I believe, or 14. And we are now rapidly growing with a combination of our open source community and our employee base here. So we are at about 700 employees now. When I joined the company about 8 months ago, I was employee 350. So in that time, we've doubled. But talking about that, it's when we release our features on a monthly cadence every the 22nd of every month, 30% of those features that are released are open source contributions. So open source is at our core. It's always going to be at our core. And as we look to expand just out of what we're widely known for is that SCM, that CI/CD piece, going on beyond that and try to make it a lot more achievable to just have, and this is trying not to do as much of a pitch here, but just give you a background of what we are, but be able to be in one spot and achieve your DevOps goals. I am not going to be diving into any of my projects or anything today, but what we're going to do is have VMware talk about a pretty interesting piece like was mentioned earlier, and that's having budget associated with that CD part of GitLab. So I'm going to easily pass it off. Didn't want to take up too much time, but if you have any questions about GitLab after, feel free to ask me, ask VMware. We can always follow up. We're pretty transparent in everything that we have about the tool. If you go to our website, you could see everything that we're doing, roadmap, anything. We don't hide anything. If you look at this page here, we talk about a DevOps tool landscape and the different tools that plug into it. And we show how GitLab matches up against them, which GitHub does quite often, CodeFresh does quite often. They come in and they say that's not right, and they contribute to it, they change it, they correct us, and we are pretty transparent in how receptive we are when we make an error. With the road mapping is a big piece. Our CEO is very, very adamant about everything is transparent about the company. He based it around that open source methodology. But any questions, let me know. Hand it back off. It's going to be a great little session. Thank you.
Is this off? Thanks, Ty. Okay. Let's get back to this for a second. Okay, so I'm just going to dive straight into the first piece. Okay. So in the example that we're going to run today, we've taken I think everybody uses this. This is the guestbook application from Kubernetes. If you go into the Kubernetes GitHub page, you can find it there. It's a great little app, very simple. Runs a front-end service and then a Redis backend. And in particular, it's obviously container-based. But what we're doing here is we're going to show you how, while you can run through a build of the PHP front end, right? And how you would run through that. And then I'm going to show you a little bit about what GitLab does at the end of it. Now, I have replicated the application in GitLab in a project. In particular, just called, think of it as the first stage of the overall pipeline that we'll show today. And I'm only going to focus on the PHP portion of it, and I'll just leave out the Redis bits. But I built a configuration file for my continuous integration piece. And what I'm doing here is I'll create two stages, right? The first stage is building the Docker image. And we're going to do that, or we did this using a Docker and Docker image. Oddly enough, that's running over on Azure right now on a compute node. Effectively, it'll build it. It puts it into GitLab's registry location. And once that stage is finished, you see there on the top, we've included a template. It's called Container Scanning by GitLab. And then it'll start a second pipeline, or second stage of this, where it actually goes in and scans that built image in the registry and checks whether or not that container image has a set of issues around it. Now, in particular, this template that GitLab provides uses something called Claire scanning. It's from CoreOS. And in this particular example, and I'm just going to jump to it for time purposes, but effectively it runs through it, and we haven't put a whitelist in there indicating, what are approved packages, right? We're just going to let it run as kind of whole. And what we'll see in GitLab is that, and I'll just show you the pipeline for a second here. Sorry. So we've run a couple of them today, but let me just kind of go into this and show you. Right, it runs two stages, and in the scanning part, it actually brings up a Docker image that will go through, load the actual container that we built in the image, run through all the checks, and then takes all of the issues that it's found and outputs it into GitLab, which will then showcase it on a dashboard here, and we can then run through all the potential issues that are there in that container image. And then based on those issues, and here obviously we've got a lot of them only because of the fact that, again, we didn't put any whitelist in there, so it's just showing everything as a potential violation. It goes through and checks all the CVEs that could potentially be there, lists them out, and that's sort of a check that you want to generally do. And it's not just on the container side like we've done here, right? And Claire is an open source tool. I forgot which one it is that it uses Claire underneath, but you can use Aqua for containers, or you can use a SAST component or a DAST component for once it's actually built and running. And GitLab is great because what it does, it effectively allows you to call one or multiple types of these components out there, and you can pick and choose. You can even build your own if you wanted to. This is a great verification check for the images and or the containers that are built before I get into the CD portion. And so this is, I think just general hygiene and really good to do. So that's a really interesting and wonderful function that I think everybody should be using. And as we look at that pipeline from end to end, this is sort of the main and I would say one of the key checks you should always do. And that if everything passes, I'll get into the deployment piece. And we'll just assume it's okay, and I'm going to hand off to Tim here. That'll kind of walk through now how do you actually go and do the budget check and kind of walk through the deployment phase.
All right. So yeah, I'm Tim Davis, and I'm going to continue here where Bill was going. He showed you the CI component and then go through and how it's going to do the container scan. It's going to show you your vulnerabilities and stuff like that. Just for the sake of making all the pieces kind of, work, we've split the CI portion and the CD portion into two different pipelines here. So I'm going to jump in and kind of show you a little bit about how the CD portion as well as the actual budget check comes together. So what we've got here is we've got the main repository. It's got the GitLab CI YAML file. So all of the CI/CD work that you do in GitLab is done through these YAML files. And I found that as opposed to using something like a Jenkins or something like that, they've actually made it really easy, where as long as you've got that YAML file in there, your pipeline's good to go. You can go through and configure a lot of the things in the UI if you're not used to codifying everything. But we've got our YAML file here. We've got a bunch of other YAML files that are used as manifests for Kubernetes. We have a Python script that we use to actually go out and do the API call to CloudHealth, which is actually doing our budget check, and we'll go over that here in just a little bit. And then we also have a policy.json file. And what this is this is where we have our budget information actually set up. So the idea of this is if you're going through and you're doing a whole bunch of this information, you're going to have a central repository with all of your policy. This is where you're going to have like your budgeting information, your security information, and all this kind of stuff. And our file actually, our Python script actually goes through and reads the budget from that JSON file and then goes through and does the check and validates if we're actually over budget or if we're not. So let's go over and take a look in CloudHealth at how we actually set up that budget check and how that actually works. So what we have here in CloudHealth is, let's go to perspectives. And if you're not familiar, CloudHealth is a platform that we acquired right around VMworld time this past year. And they are, as far as most people are concerned in Amazon, the industry standard for cost maintenance as well as governance and some other stuff. A very large amount of Amazon workloads are managed through CloudHealth. They're a big name in the public cloud industry. We thought bringing them in would be a perfect, kind of show to the community of everything that we're doing to push into public cloud, as well as working with a lot of great people and being able to do a lot of really cool stuff. So they operate around an idea of perspectives. Now, when you go through and you load up all of your different accounts and everything into this platform, if you're a really, really large company, not everybody needs to see everything. They don't need to see reports based on everything. So they have what's called a perspective. So say you're the engineering manager and you're over 3 specific applications. Well, you're going to go and you're going to create a perspective on all of the information within the cloud that pertains to your 3 applications, so that you're only seeing what you need that's relevant to your job. As opposed to like the chief financial officer who really needs to see everything, so they would have everything loaded into their perspective. This just kind of allows you to really fine-tune exactly what you want to see. And what I've done for the sake of this is I've actually gone through and created a perspective called GitLab Meetup. And with this, the place that I'm actually deploying the test application to is an Azure Kubernetes cluster, so AKS. So what I've done is I've actually gone through into the perspective and I've created the perspective based on everything set up for that Kubernetes cluster. Now, in Azure, when you deploy an AKS cluster, it asks you what resource group you want it in. Of course, Azure resource groups are kind of their folder structure for how things are split up. Well, when you deploy that AKS cluster, it doesn't necessarily put the underlying resources for that cluster within that resource group. It creates an entire new resource group for all of the information to kind of keep it there. So all the VMs, the load balancers, the IPs, everything associated with that cluster. So I was actually able to create that perspective really easily because I just went into Azure, I looked up the resource group name, and I just added that resource group to the perspective. So now, if we actually go through and look in here, we've got 24 assets. Now that's all of the VMs where all of the nodes are running, that's all of the IPs, that's all the load balancers, that's all the disks. Everything associated with that AKS cluster is now in this resource group. Now what we can do is we can go to reports and we can go to saved reports. Now this is a report that I set up where I just basically went into like cost and current cost and ended up saving the report. What this is showing us is how much we've spent so far on this cluster for the month. So on disks, we have $7.57. For virtual machines, we have $38.12. Now, with this, what we can do is we can actually set up the API call from anywhere make a call in and say, how much money have we spent this month? Based on the fact that we know what our budget is, we can actually go through and set that within the policy.json file in our repository, and then we can come through, query it. They'll tell us how much we've been spending. We know how much our budget is. A little bit of math magic, and all of a sudden we know if we're over budget or if we're within budget. So let's jump back in there, if this would get out of the way. Come on, you can go. There you go, all right. So let's take a look at that Python script. Come on. What? No. Waiting for GitLab.com. I need the Jeopardy music right now. Okay, so what we're doing is we're going through, we are looking at all of our imports, we're going through, we're setting up our logging. Now we have our API key and everything set up here for the API, we have our header. Don't worry, that API key no longer works. So, we have a policy, so we can actually go through and we're reading that policy.json file. Then we're going through and we're doing the API call. We're checking for what the cost is in there. We're going through and we're doing a check cost. So this is where we actually parse the JSON that comes back from the API call, and we're actually checking for the budget value that's in that file. At that point in time, we can go through and we can check versus that policy.json file that we pulled, do the little math magic here. Now, if we are over budget, it's going to come through in this dump file here, and it's going to create a file called overbudget.txt. This is actually the magic of how we got the logic within GitLab to work. Because what we needed to do is we needed to run a script from within the pipeline to say, if we're over budget, cancel the pipeline. We don't want to deploy any more resources because we're over budget. We don't want to spend any more money. If it is okay and it's within budget, then we'll go ahead and move on to that next stage. So that overbudget.txt file is kind of the magic of where we make that work. Now let's go in and look at the pipeline configuration file here. So we have two stages. We have test and we have deploy. Now for the test, we're using a custom container image that I built. It's based on Alpine Linux. It's got Python, it's got kubectl in it for processing stuff. The pre-script that it's actually running, one of the cool things is with the GitLab CI configuration, when you configure an image container and everything for that, and it goes through and it starts running the stage, it does a lot of this stuff for you. You don't have to do a git clone or anything like that. It automatically imports everything in the repository in that container, so I don't have to do the git clone or anything. It's just I can go straight through, take the Python file, mark it as executable, and then run it. Now, with the way that that works, again, if we're over budget, it's going to create that overbudget.txt file. If not, it's not going to. Once that's finished, I'm going to run an after script, and all of that's running from within this same container, and it's just going to do a bash if-else fi. And it's just going to say, if that file exists, then I need you to exit with code 1, which means it's just going to cancel out the pipeline, and it's not going to execute. And it's also going to echo over budget into the command line so that we can kind of see why it canceled out. Anything else, it's just going to stay within budget, continuing, and it's going to move on to the very next stage. Now, the next stage for the deploy, we're not doing anything fancy here. We actually are using now a Bitnami container, and we're doing this kind of, highlight one of our newest acquisitions here that we just brought into the fold, which is Bitnami. I've also got another blog on cloudjourney.io about all of their turnkey containers. They've got a whole huge catalog of containers that you can use for tons of stuff. They've got things that are loaded with Python. They've got things that are loaded with kubectl, Git, all kinds of different things. You can use the pre-made containers. You can use them for stuff like this. You can use them in production. Or you can just go in and you say, I want to build my own container, but I don't know how. just rip off their Docker file and make your own. It's really cool and really helpful, and really all we needed the container in this stage to do was have kubectl there so we could do those applies and then push out those manifests to the AKS cluster that we have configured. Now let's actually go look at the pipeline. Where is it? CI/CD pipeline. All right. So we'll go in here. We were definitely messing around with it a lot. I've got a lot of failures in here, so we finally made it work. It was an interesting learning curve for us, trying to figure out how we could make that logic in the pipeline work so that we could fail it on purpose. But coming to find out that we could just simply run bash commands from the after script kind of made everything come together. So what we can see here is it's actually coming through. You can see that it's loading the container. It's looking for the GitLab runner, and this is kind of the brains behind the operation that go through and goes out and runs all those commands and everything that you have set up. It automatically comes through. It does fetching changes. So what it does is it's basically doing that git clone behind the scenes so that it's pulling in everything from the repository so that you can see it. Then we're doing that, chmod plus X, so we're making that script executable, and then we're running the script. One thing, we don't see over budget printed out here, so obviously we're within budget. We can see that it's going through and running that. Everything's good to go. So then we're going to the next stage, which is going to be our deploy stage. Now with this, we can see that it's coming through, and since in the CI file, we've actually pulled a different container. Now it's actually going to load up bitnami/kubectl. So it's going to pull down that container. It's going to pull the runner on it, and it's going to start running. And then it's going to come through, and all it's going to do is do the kubectl apply, and it's going to show the YAML files. Now, one thing that you may have noticed is when I went into the YAML file for the pipeline configuration, I didn't tell it where I was deploying anything. I didn't have to say, this is where it's going, this is what you connect to make it work. That's another really cool feature that GitLab has when it comes to setting up a repository and all the cool integrations and tools they have. We can actually come to operations in Kubernetes, and you can completely configure a Kubernetes cluster directly to that repository, so that no matter what happens when you're running that pipeline, it's automatically going to be connected to that Kubernetes cluster. You can also connect to serverless infrastructure if you're so inclined. Now, I will stay off of my high horse about the word serverless because I think it's dumb because there's servers involved, but whatever. We're not here to talk about that. So we can come through here and look at the cluster details. So I gave it the API URL of my AKS cluster. I gave it the CA certificate there, and I gave it the service token. So when I'm running that kubectl apply, it automatically knows, hey, I've already got a Kubernetes cluster attached to this. I'm automatically going to do that. So that takes out an entire level of configuration in that YAML file that you don't have to do. Now there's actually a pretty cool other integration that they have here that I used originally when I was testing this out, and it's a GKE integration. They have it set up in such a way where you can go through and say create new GKE cluster. You give it your authentication and it kind of sets up a OAuth integration over into GKE. It will deploy the cluster for you. It will deploy their runner and everything for you. It configures the whole thing. It makes itself a service account. It pulls in the CA certificate with very few clicks. It's extremely easy. It's very cool. It's very quick. And it's a lot easier than bringing your own Kubernetes. So if you really don't care where you want to put it, that's a great thing to check out. If you do have your own Kubernetes environments, really it doesn't matter as long as you have full access to it. So you've got the API URL, you've got the CA certificate, you've got the token. It doesn't matter where it is. As long as you can get to it from the internet, you're good to go. Just go ahead and configure it there. Yeah. I think that's about it. Did I forget something? I don't think so. What? Oh, do you have more?
Any questions, guys?
Yeah. Any questions, comments, concerns, anything like that?
It's just, let's just summarize quickly. So I think, just a quick summary, right? I mean, I think what we tried to show you today is, specifically, obviously, we showed you how you can actually manage your budget in a deployment. But I think in the broader scale, right, you're going to want to do checks like this, utilizing lots of different components that you need, and it's really based on your requirements. You know, we went over how you can do container scanning or image scanning and how that's really usable with GitLab, and GitLab has a lot of capabilities around that, and just the ease of use there, right? And then add the API calls that we did in CloudHealth, and use your tools that you need to get that process to where you're comfortable with it and get to a higher quality kind of point, right? That is repeatable and meets all your requirements.
Yeah, and one thing that you'll notice is like the API call that we did in the Python script, it didn't require there to be any integration or anything done through GitLab. They give you the ability to do whatever you need to from the CI/CD pipeline. So as long as whatever third-party service you want to do for security or for budget checks or for any other pieces of that pipeline, you have the ability to go program whatever. If you can make an API call to it, cool, you can run a script against it and you're good to go. So it's not like you're locked into their services or anything like that. It gives you a lot of freedom.
Yeah. And definitely check out our website and check out VMware and take a look at CloudHealth and Secure State and some of the other components that we have that can help you on some of those checks that you want to do, whether it's compliance, budget, performance, etc. Okay. Questions?
Thanks for your time. We appreciate it. Oh, yeah. Yes, sir.
What do you do after Bill's budget? What do you guys do from this perspective? Like, you don't have that budget. When's the next cycle?
So, because this is a hypothetical thing and this isn't actually for our business, at that point in time, you can literally go through and, I mean, like we have, you know, all sorts of cloud accounts for our team and stuff like that. If you realize you're over budget, go in and clean stuff up, or realize, hey, I need to ask for more money, and then maybe you can up that policy.json for that. Every business is different. This is just giving you the ability to say, well, I'm over budget and I need to do something about it, and we're not going to deploy out so that we're even more over budget.
And I think, you know, so yeah, I mean, just to add to that, if you go into CloudHealth as an example, right, specifically, we did, and he showed you the UI, you can actually get in there and see who is potentially violating or potentially in, let's say, that project. In this case, there are probably multiple people accessing not just the cluster, but other components. You can find out where those violations are and are over budget or overspend, right? And then potentially work with them to shut them down, or if you've got access and you know that they're not supposed to be using it, like idle components, you can get rid of those with remediation action. Right?
It was literally just this afternoon that Sean on our team just randomly asked somebody, hey, who has an EC2 instance deployed in Ireland? That came from CloudHealth, and all of us were like, I don't know, we have no idea.
Yeah,
well, we were able to go through, pull it up in AWS, and see that we had an instance that had been deployed back in November for a VMware code, you know, demo, and it just got left there. Now, that wasn't hindering our budget or anything at the time, but that kind of shows you can actually take that tool and say, what do we have out there? Why are we spending so much? And sit there and actually pull through the resources and be able to go through and then clean that up.
Yeah. I mean, it was idle. We knew we could shut it down. We knew who it was, so, but at least we had all that information, right? But yeah, it's a pretty powerful tool from that perspective, yeah. Okay.
Excellent.
Okay. Thank you.
Thanks for your time, y'all.